So the Wronskian is a generalized method that checks if two or more, if any, let me put it this way, y1, y2 are linearly independent. Okay, so that's the, definition. So for two second order case, the Wronskian is defined as like this. Definitely, it should be a function of y1 and y2, right? Because it's comparing y1 and y2 and checking if it's linearly dependent or independent, right? So it has to be function of y1 and y2. Okay, in second order case, right? y1, y2, y1 prime, y2 prime. Okay, this is not absolute sign. This is determinant. Okay, so it's a determinant. I hope you know that. And the calculation will be, determinant calculation is this, right? Okay, that's the definition of Wronskian. Okay, we make it. We made it. Wronskian made it. Wronsky is a Russian or that kind of mathematician, I guess, right? And then he suggested this method to check if it's linearly independent or not. All right? And if the calculation of this becomes 0, then it's linearly dependent. Okay? This calculation becomes 0, then that's linearly dependent. Not 0, then that's linearly independent. Okay? So that's Wronskian. And I told you this is the most generalized method, right? So it's not only second order, we can expand it to nth order. Okay? Like this. Wronskian of y1, y2, y to the n, right? So nth or differential equation, let's say, right? Then y1, y2, yn. Okay? y1 prime, y2 prime, yn prime. Okay? And y1 to the n minus 1, y2 to the n minus 1, yn to the n minus 1. That's the fully generalized Wronskian to the nth order. You can check the linear independence of n functions. Okay? So this example, y1 is x squared, y2 is x times absolute of x. Okay? That's very, confusing many times, right? So what is Wronskian of those two? Are they the same or are they different? And how different, Actually, the graph of two functions, okay, is this. That's x squared. That's x times absolute of x. Okay? It's the same quadratic, but due to the, this absolute, that has a different form. Okay? And we have to check if it's linearly dependent or not. So let's see. We need a special mathematical operation for this type, right? This is not normal. This is absolute times something. It's not normal. We have to make it, specialized way. So y2 is we can always do this, right? X times square root of x squared. The special thing is, this is x squared is first, right? In mathematical operation wise, the inside has to be done first and then square root, okay? It's not at the same time, then it cancels and it becomes x squared. But actually, it's the x squared is first. It's operated first, okay? And we can make it, in that respect, we can make it like that, okay? And we have to differentiate this. So x squared, chain rule, right? Differentiate x first, and then this one left, right? Plus x left, and this one is 1/2 x squared minus 1/2 times the chain rule inside of the x squared. That's okay. It's just a chain rule, right? And rearrange it a little bit. X squared 1/2 plus x squared times x squared minus 1/2. Okay? It's, so the key is we're, keeping x squared because it's always done first, right? So we are keeping it, until the end. So that's x squared times 1/2, right? And we have two of them, right? So in mathematically, this is it. So let's check Wronskian. So W is y1, y2, y1 prime, y2 prime, which is x squared, x times x squared, 2x, 2 square root of x squared. Okay, and you do the determinant calculation. X squared minus 2x squared square root of x squared, which is 0. Okay, so they are linearly dependent.